All right. So question. This is from the 2003. It's calculator question. It says, let R be the shaded region bounded by the graph y equals square root of x and y equals e to the negative 3x. And the vertical line x equals 1, as shown in the figure to the left. Find the area of R. And remember, you have a calculator. So you should be able to tell which one's which, but in case you don't, this one up here is y equals square root of x. And then this one right there is y equals e to the negative 3x. And then this line is x equals 1. Cool or not cool? Yeah. All right. Here's what you're going to do. In your calculator, I would type this into y1 and this into y2. I would never use y1 and y2 when you're doing your exam. That's just how you type it in. So I'm going to go y1. I'm going to go square root of x. No, they're asking, oh, that's polar. Reset it. Second memory 712, and it'll go back to regular. Or you can go to settings. Yeah, the last class guys did it in polar, so e negative 3x. I never gave you a calculator for this?
You did.
Okay. Oh, charge it, miss. You're funny, miss. All right. So here is the window. So look, notice that it goes from 0 to 1. So I'm going to go a little bit to the left of that, and same with the y value. So I'm going to click on window, and I'm going to go a little bit to the left of that, negative 0.5, bless you, to like 2. And y min negative 0.5 to like 2. And there it is. And if I had x equals 1, it would have cut it right through here. I need that intersection. So I go second, calculate number 5. And I'm going to push enter twice. And it should say the word intersection. Do you guys see that? All right. So how do you write it on here? Here's how you write it. You need to find the intersection. So you would go square root of x equals e to the negative 3x. Now, this is a calculator question, correct? You do not need to show the arithmetic. You just tell me where these two are equal. Where are they equal? They are equal at, and I already forgot the number. Let me go to my calculator. 0.2387341. 0.2387341. And then I like to use arrows to indicate that I'm storing it into a letter. That is perfectly acceptable on an exam. I'm going to say that I'm going to store it to letter A. I always go down the alphabet. Are we okay so far? Okay, so I take my calculator, and I'm going to store it to letter A. So I go to the home screen, second quit, and if you push X, push enter, and look, there it is. That's the value. I push the store button, alpha A. And now every time I use A, it's going to be that number. Cool or not cool? Cool. And now I'm ready. Here we go. It says find the area of region R. So I go from this, which is point A, all the way to what's my x value? 1. So I'm going to go region R equals integral. And I already put here what A is. So I'm just going to write A all the way to 1. And then I got to go top curve minus bottom curve. Which one's the top curve? So I write square root of x minus the bottom curve is e to the negative 3x. And you can put a dx, or if you want, you can put that in parentheses. It doesn't matter. There it is. You're showing it. This is called the setup. And then give me the answer. So I take my calculator. You do not have to show antiderivative by hand, because this is a calculator question. You take your calculator. Remember that I have square root of x and y1 and e to the negative 3x and y2. Guys, don't work harder. Work smarter. Math, number 9. And then I'm going to put A down here, alpha A, all the way to number 1. And then remember, the square root of x, I have it in y1, so alpha trace y1 minus alpha trace y2. And then I put an x here, and then you are done. 0.4426. 0.4426. You do not want to see calculator talk? So that means you do not want to see the y1 and y2. Nowhere in here do you define y1 and y2. Maybe you could define this to be y1 and y2. I don't recommend it. Just show this. And there it is, full credit. Cool or not cool? Cool. So do you guys want to see if you guys can get this question on your own? Question number 2? All right. Try it. Try your best. And then in 2 minutes, we'll see what's up. Upper minus lower, you subtract. Even though it's below the x-axis, you still subtract. Upper minus lower. All right, I'm going to go ahead and get started, guys. If you're close to getting an answer, keep doing your thing. Bless you, Q, bless you, fourth power. How many? Fifth, that's the fifth power. Dang, is that a new record? No? Okay. Let f and g be the functions given by, and look, they give them a name. They call this f, they call this g. You can use f and g. The graphs f and g are shown in the figure to the right, so they show you that this is f. I'm going to put this into y1. I'm just writing this for notes, guys. I would not write y1 or y2 anywhere in that answer document. Cool or not cool? This is just for notes. I'm going to put this into y1, and I'm going to put this into y2. So I go to y1, and I'm going to type in, what am I typing? 2x parenthesis 1 minus x. 2x parenthesis 1 minus x, close. And in y2, I'm typing 3 parenthesis x minus 1 square root of x. Okay. 3 parenthesis x minus 1, close it, and square root of x. Bless you. All right, so I got my y1 and y2 situated. So now let's see. I can see from the graph that they both start at 0 and they both intersect at 1, and it's confirmed by looking at this from your algebra days. If you plug in x equals 0, you get a y value of 0. And if you plug x equals 0 in here with the square root of x there, you get a y value of 0 as well. And then if you plug in a 1, you get a 0 as well. If you plug in a 1, you get a 0 as well. So when I say you get a 0, the y value is 0. So these are accurate, 0 to 1. So here we go. This region, integral, from what to what? 0 to 1. What curve is on top? So I'm going to write f of x minus, what curve is on bottom? G of x. And if you want, you can put it in parentheses like that and put a dx, or you can just, not put parentheses and just put dx, but I like to put parentheses so I can see that it's a Riemann sum, length times width, width times height of the rectangle, right? Right. All right, there it is. Now all I got to do is give the answer. So I take my calculator and I'm going to go to, here's my home screen. Let me start it from scratch. Math number 9, from what to what? 0 to 1. Where's my f located in my calculator? Y1. How do I get Y1 in here? So I'm going to push alpha trace. I push Y1, enter. Minus, how do I get G? Alpha trace, and then Y2. And there it is. I push X, and I push enter. Did you get 1.13333? There it is. That's the answer. 1.13333.
Dude, I still didn't say that I was tweaking.
Cool or not cool? Okay, here we go. This is a full-blown free response contextual question. Do you guys want to see if you guys can figure it out first, or should we just go right into it? Yeah, read it. See what you guys can. Let's see if you guys can do letter A first. We'll go read the whole situation. Take 2 minutes. See if you guys can do letter A, and then we'll see if we can figure it out. You can use a calculator. Go ahead. All right, let's see if we figured it out, guys. Let's read the question really quick. Let's see if we first know what's happening. There are 700 people in line for a popular amusement park ride when the ride begins operating in the morning. Okay, makes sense. So there's people in line. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. Okay, makes sense. Fiesta, Texas or something. While there is a line, people move onto the ride at a rate of 800 people per hour. So this is kind of like how many people are entering the ride. Like it's like the out. Okay, don't worry. Let's read so we can see what's up. The graph above shows the rate at which people arrive. So this is arrive. So this is kind of like an in at which people arrive at the ride throughout the day. And then, so let me go back. While there is a line, people move onto the ride. Sensitive. People move onto the ride at a rate of 800 people per hour. So this is out. So this is how many people arrive at the line. And this is how many people the ride is spewing out. 800 people per hour. Make sense? The graph above shows the rate, R of t, at which people arrive. Yep, arrive at the ride throughout the day. Time t is measured in hours from the time the ride begins operation. Yep, there it is. And it operates for 8 hours. Letter A. Let's go slow. How many people arrive? So I'm looking at this graph. at the ride between t equals 0 and t equals 3. Show the computations that lead to your answer. How do I get that? Between t equals 0 and t equals 3, I want to know how many people arrive. How do I do that? Yeah, I found the area under the curve. And if you find the area under the curve, that will tell you how many people arrived. Do you guys see that? I see 2 trapezoids. Let me see. Yep, I see 2 trapezoids in the side like that. See, this is my base. It doesn't matter. You can cut it up into as many pieces as you want. So here we go. All I'm doing is I'm going to write an integral, guys, because that's what I'm doing. I'm finding the area under the curve. So let's see. What is this? R of t? I'm doing this integral from 0 to... Oh, yeah, on A. Why am I writing it on B? Integral from 0 to what? 3 of r of t dt. This is what I'm doing. So, all I'm doing is using trapezoids. My first trapezoid has a height of 1,000 plus the next height is 1,200 and then times, or I guess base 1, base 2, sorry, times the height, which is 2, which is the delta x, divided by 2. Does everyone know how I got that? Plus, the next one is going to be 1,200 plus 800 times 1 divided by 2. And then I take my calculator and I go really slowly on my calculator with that. So let's see, these 2's cancel out. So 1,200 plus 1,000, that's 2,200. Plus, and then that's 2,000 divided by 2, so 1,000. So did you guys get 3,200? And then I put units, 3,200 people. You could also see people per hour times hours just gives you people. How do we feel so far? Nothing crazy, right? All right. See if you guys can figure out letter B. Take 2 minutes. I like it because it shows that you're not a robot. Let's see if you guys can figure that one out. You don't even need calculus for that one. You just need like context clues and know how to interpret what's happening. You don't need to do any calculus. I love that question. Critical thinking, guys. Shall we talk about it? You need to know the context of the question. Read it. Well, I mean, I could be wrong too. We'll check the key in a little bit. I haven't looked at the key, guys, so I don't know. But I do know. Well, and the people arriving, is it greater than 800? You're looking between 2 and 3 hours. Right at 3, I guess it stays the same. All right, let's talk. Look, there's not even calculus, guys. It's the foundation of calculus. It's the concepts are calculus, but it's not even calculus. So think about it. So remember, the ride, as long as there's a line, the ride can push out how many people per hour? 800. Now it's asking between 2 and 3. Between 2 and 3 is the amount of people per hour arriving greater than 800. Yeah, look, at 2 it's 1,200 per hour, and right at 3 it's 800 people per hour. So as long as there are more than 800 people arriving per hour, the line is going to be getting bigger or longer. Does that make sense? Yeah, because the right can only push out 800 people. So if there's more than 800 people per hour coming in, the line's getting longer. Does that make sense, guys? So that's what you write. You write since. So I'm gonna put a line right here. While there is a line, comma. While there are people move onto the right at a rate. So I'm just gonna write that verbatim. People move onto the ride at a rate of 800 people per hour. And then now I'm going to start my sentence. So that I just wrote verbatim from the script. While there is a line, people move onto the right at a rate of 800 people per hour. Between t equals 2 and t equals 3, comma, r of t is greater than, I guess you could also say equal, because right at 3 it equals, no, I'm just going to say greater than, because you know what, I know how I'm going to say it. Sorry guys, I didn't look at the rubric, so I'm trying to think of how they probably could. Between, and look, notice that I'm going to put parentheses, so then I don't have to mess up with any technicality. Between 2 and 3, comma, r of t, is r of t always greater than 800? Yeah, it is. Between 2 and 3, I didn't put equal at 3, but between 2 and 3, r of t is always greater than 800, comma, hence, comma, the line will be what? Increasing.
Would it make a difference if you wrote 2 and 3 in parentheses? Would it be better in parentheses or brackets?
Parentheses, because right at 3, it's exactly 800, but you're still technically increasing. I guess you could have also put r of t is greater than equal to 800, and if you use the bracket, you know what I mean? And you'll still be fine, because you didn't say anything wrong.
So then would the graph show that it's still increasing just at less like rate, like this?
Oh yeah. The line is increasing at a slower rate, so it's still getting bigger, but not as fast.
Okay.
Does that make sense? Yeah. But that's not what they were asking. They were just asking, is the line getting bigger or not? But they were not asking that. They were just asking, is the line getting bigger? Cool or not cool? Isn't that question awesome? Because it gives the students a chance that are not super strong with calculus to get it right, even if they're not super strong, because they know the concept. All right. Letter C. At what time t is the line for the ride the longest? How many people are in line at that time? Justify your answer. I don't know if we know enough. Let me see. Do we know enough? Okay. Yeah. No. You're close. All right. Yeah, look, you're close. When is the line? Look, that's why we answered letter B. When is the line the longest? The longest.
When no one has gotten it?
When I hit what time value? Not 2. Remember, you just told me guys from 2 to 3 that my line is still getting bigger.
I don't understand that part of it though.
The line is still getting longer. It's just getting longer at a slower pace. But it's still getting longer. At 3. Okay, tell me, Flores, because I want to make sure to answer your question.
I'm pretty sure I know what it is.
So this is just saying the amount of the rate of the people that are.
It's just saying, no, not the rate. Just the line. Is the line getting bigger or not? Maybe, okay, I know, because you see the line going down right here, and you're like, wait, it should be going down, decreasing. Yeah, the rate at which people are showing up is decreasing, but the line is still getting long. So this is what it means. At my first moment, there were 10 people that showed up. All right, guys, real quick. So pretend that there's no one going into the ride, right? So right now there's 10 people lined up in the first 10 seconds. I'm making this up compared to that. The next 10 seconds, 5 people show up. The line's getting longer. Now there's 15, but it's getting longer at a decreasing rate. The next 10 seconds, 3 people show up. But look, no one has gone on the right. The line's just getting longer and longer. It's just getting longer at a decreasing rate. So the amount of people showing up in that line is getting less. But the line itself is getting longer.
It's because what I think, what I think is that 800 people per hour.
That's a rate.
So, like, when I'm thinking in my brain, oh, by the time they get to 1 hour, all these 800 people are gone, and then we're left with these people. And so the second hour, yeah, no.
No, I know what you're saying. Okay, I just want to make sure.
Yeah, get on the
Yeah.
ride and the line.
We are going to calculate that right now. We're going to calculate how many people are still there on the line. This ride can handle 800 people per hour out. Yes or no?
Yes.
All right. And then right now, if this is an in-out problem. This is how much are going in, and this ride can take 800 people out. So as long as there's more than 800 people coming in, we're gonna have a line. Because it can only take people out 800 people per hour.
We're gonna have a line, guys.
Does that make sense?
I get it. I get it.
Okay. So now let's get back to the problem.
As long as it's above the x-axis, then it's increasing.
Yeah, so like 800 would be like that x-axis.
That's like the max.
Correct. All right, guys. So this is an in-out problem. So again, let's try. Look, we're just starting out. We're rookies. We only get better with experience, guys. So that's why I tell you all the time to please look at your calculus and do some math problem when you get a chance. All right. At what time? So first we got to answer the first question. At what time t is the line for the ride the longest? It's the longest at what time value? T equals 3. So I'm gonna answer that first. Line is the longest at t equals 3. And now it's time to answer this question. How many people are in line at this time? All right, you guys ready? So I need to know people at t equals 3 is going to equal, well, how many people were there initially? I think it was 700, no? There are 700 people in line for a popular amusement park. So that's the initial amount, 700. And I'm going to add how many people have gone in line between 0 and 3, which you already got it on letter A, plus the integral from 0 to 3 of r of t dt, which was 3,200 people. And now I need to subtract how many people came out. 800 times 3. Why am I doing 800 times 3, Flores?
800 people who join the ride every hour.
Because how many people come out of the ride? 800 people per hour. Does that make, that's a linear one. So 800 times 3. There it is. That's going to be the total output of how many people are still in line. So let's see, 700 plus 3,200 minus 8 times 3, 8, 16, 24, 2,400. So what is that? 1,500? In a little bit, 1,500 people. In a little bit, we'll look at a rubric to see how close we are. I'm pretty sure the rubric's probably going to look almost identical to this because there's really not many other ways to do it. They might use fancy, we'll see right now. How do we feel? All right. All right, let's see what it says on the next integral, on the next equation. Write, but do not solve, an equation involving an integral expression of r whose solution gives the earliest time t at which there is no longer a line for the ride. Okay, well, look, they kind of set us up because with letter C there. So let's see if we can write an equation. People in line equals the initial amount, 700, plus how many people went into the ride. So that's the R of t, right? From 0 to sometime t. So 0 to sometime t. Put an upper limit of t. R of t dt. And I got to subtract 800t. And all this better equal what? If there's no longer a line, 0. All right, let's look at the rubric and see how we did. Let's look at.
He's like wrong.
Oh, that would suck. Let's see. What year was this? Response.
I get C, but I don't think I would have come to that conclusion.
Okay, how many points is this? How many points is every free response? 9. So here's the moment of truth. It is the first time of myself seeing this. I mean, I've seen it before, but it's the first time this year seeing this. All right, so let's see. Letter A. Did we get the 2 points? Notice that they give you a point for the integral. So make sure that you put that integral there because look, they give you a point. And oh, by the way, did we get 3,200 people?
Yes.
Did you have to do the arithmetic to get to 3,200 people? If you are scared, and we're not teaching to the test, guys, but if you are scared, you can leave it. You can actually leave it alone right here with these two like that. As long as it's a numeric answer with plus, minus symbols, multiply, whatever, that's an answer. Of course, I encourage you to be brave and put 3,200. Oh, man. Let me put it back in there. 3,200. That was what we got, right? Yeah. So we got it. Okay. All right, here we go. Let's go to the next one. So we got the 2 points. Letter B. Let's see how they wrote it. The number of people waiting in line is increasing because people move onto the right at a rate of 800 people per hour, and between 2 and 3, notice they didn't put equal signs, R of t is greater than 800. I kind of like ours better, but I like how theirs flows nice and smooth. Does that make sense, guys?
Yeah.
All right, 1 point. Oh, it's just one point. All right, letter C. Okay, look at this. Identifies t equals 3. If you identify it, that gives you a point. R of t equals 800 only at t equals 3. Between 0 and 3, R of t is greater than 800. I didn't say that, but I think we still would have been okay. Between 3 and 8, R of t is less than 800. Therefore, the line is the longest at t equals 3. Maybe the justification. No, it just says identifies. I think we still would have been okay. There are 700 plus 3,200 minus 800 times 3. So notice they didn't write it the way I wrote it, but it's really, yeah, I wrote the answer. I prefer my answer over their answer, but that's fine. 1,500 people waiting in line at time t equals 3. Cool or not cool?
Well, I would think we get the justification for we didn't write anything.
Oh, we didn't write anything?
No.
Ah! Okay, so maybe we lost a point because we didn't justify. You always have to justify. When do you have a max? When do you have a min? Okay, so maybe we lost a point there. See, so good thing we're starting now. So, all right, look at letter D. They wrote the equals 0 right off the bat. I don't like that, but that's fine. Initial amount plus 0 to t of r. They changed the letter to s. I like ours better. R to dt minus 800t. I like ours better, but whatever. We got all 3 of those points. So if we were taking this test, I think it's safe that we would have gotten 8 out of 9 because we didn't justify like the way we should have.
Can we justify now so I know?
Oh, we're gonna practice a whole bunch. Yeah, go ahead and just we're gonna practice. We're gonna practice.
Wait, so the justification is the middle part, right?
Yeah, between 0 and 3, RT is greater than 800. Between 3 and 8, it's less. Therefore, the line is longest at t equals 3.
Do they really need to explain that?
No, yes.
They know that.
No, well, that's why they're right. It's like when do I have a maximum? When the derivative changes from positive to negative. Hence, it's a max. So that's kind of like that. You know what I mean? Yeah, when the yeah. It doesn't matter. It's a dummy variable. You can call it dx, dv, du, dt. I like ours better. It's a dummy variable. As soon as you do the antiderivative, you're going to plug in a t, and you're going to have a t in your expression. Well, it's because they don't want to have the top variable the same as the bottom variable.
Because it's like the way I'm seeing the way that they.
Oh, sorry. Let me put it back.
It's like a whole different. I updated my binder. I'm like, you should be proud. Yes.
All right, guys. I think they're testing a few rooms over to the left. Guys, we have a lot of time. We have half the period. I did this on purpose. Please make sure you're working on calculus. Some of you guys have a lot of stuff that you have not turned in, and it's getting pretty close to the end of the... So come on, guys. Do some calculus, please.